So let us try to analyze this question. Sine inverse of 3 by 5 minus sine inverse of 8 by 17 is equal to cos inverse of 84 by 85. We need to prove this. Let us start with the LHS and see whether it is equal to the RHS. So there are two methods. So directly you can deal with sine inverses and use the formula corresponding to sine inverse, or you can convert both of these into tan inverse and go forward. So I'll do it by both the methods. So sine inverse of x minus sine inverse of y is sine inverse of x into root of 1 minus y square minus y into root of 1 minus x square. So for sine inverse x minus sine inverse y, you have only one formula for all cases. That is equal to sine inverse of 3 by 5 into. So what is 8 by 17? 1 minus 64 by 289. That is equal to 225 by 289. So if you do the square root of this, you get 15 by 17. So this is 15 by 17 minus 8 by 17 times 1 minus 9 by 25 is 16 by 25, 4 by 5. That is equal to sine inverse of 17 into 5 is 85, 3 into 15 is 45 minus 8 4s are 32 is 13. So sine inverse of 13 by 85. That is equal to cos inverse of what? We know that sine inverse of x is cos inverse of root of 1 minus x square. That is equal to cos inverse of, so root of 1 minus, so 13 square is 169, 1 minus 169 by 85 square is 7275. So 7275 minus 169 by 7275. So 1 minus 169 by 7275. So if you do the calculations, so you get the numerator as 84 square, the denominator is 85 square. So cos inverse of 84 by 85. So this is what you're asked to prove. Now let us also try to convert this into tan inverse and get the answer. So you have understood how to convert one inverse trigonometric ratio into another using triangle method. So if you draw the triangle corresponding to the first ratio, so if this is alpha, the opposite side is 3, the hypotenuse is 5. Hence the adjacent side will be equal to 4. If you take the second ratio, the corresponding right angle triangle, let this be beta, opposite side is 8, the hypotenuse is 17. So if you use the Pythagoras theorem, root of 169, root of 289 minus 64 is 225, root of 225 is 15. Now, sine inverse of 3 by 5 can be written as tan inverse of 3 by 4. And sine inverse of 8 by 17 can be written as tan inverse of 8 by 15. Now, tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy, which is equal to tan inverse of 45 minus 32 is 13 divided by, the LCMs will anyway get cancelled out, 60 plus 24 is 84. So now finally we'll try to convert tan inverse x into cos inverse. So let us again take another right angle triangle. Let us be gamma. The opposite side is 13, the adjacent side is 84. So the opposite side by Pythagoras theorem will be equal to 85. So tan inverse of 13 by 84 can be written as cos inverse of 84 by 85. So this is what you're asked to prove. Thank you.